My name is Chris DePree, and I am Deputy Spectrum Manager for the National Radio Astronomy Observatory and Project Director for the National Radio Dynamic Zone Project at NRAO. I was a professor of physics and astronomy at Agnes Scott College in Atlanta, Georgia, and I was there for 25 years. And I arrived here back at the end of July in 2021. NRAO is an observatory, as its name implies. We operate telescopes in several locations, but we are also, of course, involved with the Green Bank telescope operations, also ALMA, and then the Very Long Baseline Array, the VLBA. The NRAO was founded back in the 1950s to build the best telescopes instrumentation in the world, and we're also involved with training scientists and engineers. It's actually part of our mission statement that we want to advance an inclusive participation in science and engineering. Another big part of what we do is trying to foster a more literate, scientifically literate society. I would probably say you could find an astronomer who would say any part of the spectrum is critically important. Typically, radio astronomers are interested in a particular problem, right? And so one problem that many astronomers are interested in is, where is hydrogen in the universe? So there's a portion of the radio spectrum around what we call the H1, which is neutral hydrogen, right? The H1 line that is hugely important to a lot of astronomers because it tells us much of what we know about the structure of our own Milky Way. It tells us much of what we know about the structures of other galaxies. It is used as kind of a foreground material to look at stuff that's happening far away. You know, we use the galactic H1 in what we call absorption. Really, there have been large efforts and kind of policing efforts to make sure that we don't mess that up. Because if we lose that, then we lose our understanding of lots of parts of the universe. The telescopes that you see behind me are some of the telescopes of the Very Large Array. There's 27 of them arranged out in the plains of St. Augustine. They steer around the sky. They point anywhere above the horizon. The resolution of a telescope is related to wavelength over diameter, right? So if you have a long wavelength, you have to have a big diameter telescope. And the earliest radio telescopes operated singly, right? You would have a single dish like one of these ones behind me. But increasingly, it became obvious that if you wanted to get very high resolution images that were competitive with optical telescopes, you would need to build what are called interferometers. And that is what the Very Large Array and the Very Long Baseline Array and ALMA, which is the millimeter array that is located in Chile, those are all interferometric telescopes. And so those use combinations of telescopes of still large dishes, right? And they use them in conjunction to form very high resolution images. And then you have the receivers on these telescopes, which are extraordinarily sensitive. They are typically cooled to low temperature to increase their sensitivity and their performance. And the levels of signals that these can detect is far below the noise floor of most instruments, commercial instruments. And that's exactly why we have to be so careful with commercial equipment being used near radio telescopes, right? Because your typical, I have all these things, a smartwatch, your cell phone, wireless microphones and headphones, those all operate in bands, that they're licensed to operate in. But the strength of their signals is calibrated to commercial use. And the signals that these telescopes can detect are far below those limits. And so even an ordinary electronic device will swamp the signal, in that particular part of the band that these instruments operate in. Radio observatories locate themselves in remote sites in an effort to stay away from the majority of radio transmissions. And that era, right, the era where radio telescopes on the surface of the Earth could avoid radio transmissions, is ending. So one challenge is simply the presence of satellite constellations. And I would say probably a bigger challenge is not the satellite constellations that are currently operating, but the next step, which is going to be 5 or more other nations deploying their own satellite networks, all of which will have their own operating schema and their own conditions, and be less answerable to whatever rules we set up in the US. The opportunity there is the opportunity to be in conversation with the companies that are developing these new technologies while they are taking shape. I mean, I think this is happening not just with NRAO, but with other radio observatories, is that the satellite constellation companies are talking to observatories, and I think sincerely care about not wanting to spoil radio astronomy, right? They really do want to figure out a way to do this, and I think that is a sincere hope. We know that there is a big challenge in providing basic services, basic broadband internet to rural populations. And if we can figure out this way forward, right, if we can figure out a way to dynamically share and dynamically use spectrum more effectively, then maybe we have an answer to rural broadband access. NRAO is working closely currently with SpaceX, which runs the Starlink satellite constellation. We do regular testing. We share our results with them. They give us feedback. We are building a system that will allow, for our pilot case, the VLA and Green Bank Telescope to share what we are doing in real time with a satellite constellation operator. So we will share, here's what we're doing, here's the frequency we're at, here's our bandwidth, and here's where we're pointed in the sky. And then based on that information, the satellite network, we hope, can make adjustments, right? And can adjust itself to accommodate what the telescope is doing at a given time. And we hope as other constellations come online, that we'll expand that group. The National Radio Astronomy Observatory hires people all across the spectrum of jobs, right? You might think only about radio astronomers, right? But in order to run a radio observatory, a national observatory, you need hundreds and hundreds of people. And so, for example, there is a dedicated crew that moves the telescopes into a different configuration. We have human resources, right? We have to sort of have services for all the people who work here. Education and public outreach, right? One of the most important things we do is to let everybody in the country and in the world know about what we're doing, right? All of the great discoveries that are being made. So, radio astronomy needs great scientists, needs great engineers, needs great writers. Some people have a talent in going out and telling others about that. Some people, that's the last thing they want to do. They want to sort of tunnel away on their interests. And that's great, right? Because all disciplines are that way, and all disciplines require all types of personalities.